Okay. Okay. So the question is saying figure 1 shows a straight line AB. Oh, whoa. Okay. Figure this figure shows a straight line AB. With I'm just reading the statement we are given with A on the y-axis. This is the y-axis over here. This is our x-axis, and B on the x-axis. So we are given information here. Okay. So AB is extended to C. Line OD. This is the D is over there. D is 4 and -6. So line OD is perpendicular to AB. Let me just join a few people. Okay, no one is there now. Okay, so line OD is perpendicular to line AB and cuts AB at point D. E is the midpoint of OD. So we are given some information already. Um, we also have formulas for gradients that's perpendicular. So gradients it's perpendicular. The formula is m of the first one. Okay, let's say m. Let's say it like this rather. M1 times M2 equals -1. And then parallel gradients M1 equals to M2. Okay, we'll get to that. So the first question is saying calculate the gradient of line OD. So O is at the origin, and at the origin the coordinates is 0 and 0. Okay, 0 and 0. So we say gradient of OD equals difference of y over difference of x. Like that. You know what we do is we substitute. We're gonna say we're gonna start with let us start with D. So we're gonna take the y coordinate of D as -6 minus the y coordinate of O, which is a 0, over. Because we started with the coordinate of D first, we're gonna start with the x value of D now first. Again. So it's 4 minus 0, which is -6 over 4 equals to -3 over 2. This is our gradient for MOD, which is very straightforward, very straightforward. So number 2 is saying calculate the coordinates of E. And we were told that E is the midpoint of line OD. So to get the midpoint, we're going to use the midpoint formula, very straightforward. So midpoint of line OD equals x1 plus x2 over 2, and for the y coordinate y1 plus y2 over 2. So all we're going to do now is we're going to substitute the x value of D and the x value of O put it in. Same with the y value of d and the y value of o. We put it in over there. So it is 4 plus 0 over 2, and it's negative 6 plus 0 over 2 equals 4 over 2 is a 2, and negative 6 over 2 is negative 3. So E, okay, the midpoint OD, that means the coordinate of E is 2 and negative 3. This makes sense because 2, it's over there on the x-axis. It's over there. Yo, can you guys see properly this thing? Okay. So 2 on the x-axis, it's there. It's somewhere there. It could be, not drawn to scale, but it could be there somewhere. And anything below the x-axis, it's negative. That's why it makes sense for us to have a negative 3 over here. But that's the question solved. Very straightforward, right? We select the correct formula, substitute, finished. Okay, the next one is they're asking for, yes. Okay, yeah, good, yeah. Sorry, man. I think that's, yeah. Okay, thank you. Okay, so they are now saying calculate the line of the. We must now determine the equation of the line AC, which is perpendicular to line OD. So we must determine the equation of the line for line AC. AC. How are we gonna do that? Okay, we first select our formula y minus y1 equals to m gradient x minus x1. Okay, so what this is saying is AC, which is perpendicular to OD. So we have the gradient of line OD, but now we need the gradient of line AB uh, to solve this one over here, because we must put the gradient of AC over here. We were told that OD is perpendicular to AB. So to determine that, we can use this formula over here. So M1 times M2 equals negative 1. Or let's rename it and say MOD times MAC equals negative 1. So MOD is negative 3 over 2 MAC, negative 1. That's on top over 1. So we do this quickly. MAC is going to equal 2 over 3. Because we are going to multiply with 2 and the negative 2, multiply with negative 2 and divide with 3. That's cross multiplying now. So we have our m value and it is 2 over 3. So now we must determine which values we're going to use. So we can use any coordinate that is on this line that we have. to substitute in here for our y value and our x value. And the only one we know for now is d. So we're going to use d. So the y coordinate of d is -6. We put our bracket. And then for x, we have a 4. So now we multiply out and we simplify. Here is a y plus 6. Here is 2 over 3x. 2 over 3 times minus 4. It's -8 over 3. All we do is we get y alone. Y equals 2 over 3x. So this comes over, it's a minus. So 8 over 3 minus 6. It's -10 over 3. Very straightforward. We are done again. Yeah, I'm correct, ne? -8 over 3 minus 6. No, it's a 26. 26. So the standard formula for a straight line, does anyone know? Anybody know? The standard formula for a straight line is y equals mx plus c. That's why we have this form here. So we need to get this form because it's the standard form of a straight line. Okay, this 2 over 3 is because we have the gradient of MOD. Yeah, it's a gradient that's perpendicular. This formula is for perpendicular gradients. Okay. The next one is saying the coordinates of point B. The coordinate of point B. Okay. Um, so for the coordinate of point B, our y value here we know is a 0, right? So we have the equation of this line. So I think all we really need to do is to say this now. So we have y equals 2 over 3x minus 26 over 3. This formula is the formula of this line AC over here, and we need the coordinate of that point B. And we have the y value, which is a 0. So all we can do is um, substitute y equals 0. So 0 equals 2 over 3. Once again, x minus 26 over 3. Now all we're going to do now is solve x. Take this over, 26 over 3, 2 over 3x. Multiply with 3. Multiply with 3, it's going to do that. So 26 over 3. Yeah, it's just 26, 2x, 13. So x equals 13. That means our coordinate for B is 13 and 0. Again, we determined the straight line formula for line AC, and AB falls in that straight line. So we know that on the x-axis, the y coordinate will always be 0. No matter where it's sitting on the x-axis, the y coordinate will always be 0. So we substituted the 0 in the formula of that same straight line. solving x. Very straightforward, these calculations. So they're asking now for the size of the acute angle between line AC again, and the x-axis. So they want the acute angle here. Let's name it 1. Okay, how do we do this? So we look at our formulas for angle of inclination. For an acute angle, we take its theta 1 equals tan second function m. So we're using the gradient of line AC because it is this line we are using. So it's gonna be AC, gradient AC. Always know which gradient you are using. Don't just use any gradient. So tan second function 2/3. All you do now is a calculator, and then we get 33.69 degrees. That is the angle of inclination for the acute angle between line AC and the x-axis. Now, just for you to know, if they ask for the angle of inclination for this obtuse angle over here, just name this number 2. For this angle over here, they ask you for this. What you do is, you say theta 2 equals 180 degrees minus tan second function MAC. Same gradient, same line. Then all you do is you say 180 degrees minus tan 2/3 equals 180 minus tan 2/3. Oh, let's see what I did. Gives us 146.31 degrees. And you can see that if we add these together, it's going to give us 180. 180 degrees is the degree of a straight line. So yeah, that does make sense. That does make sense. So this angle here plus this angle here must give me my full 180 degrees for a straight line. And that is true here. It's proven over here. That's why we say this 180 minus tan for the obtuse angle. This is for the acute angle. This is for the obtuse. That's for the obtuse angle. Is there more questions here? Let me see. No, that was the last one. Okay. Is there any questions regarding this work? It's very straightforward, right? Yeah. So you don't know what the gradient formula is, you don't know the midpoint, you don't know which go with which. I see. For me, this is like for me, it's like they ask you gradient. All you must do, you see which coordinate is on the gradient of the line they want, you substitute. They ask for the midpoint. You look which coordinates is opposite that middle point, you substitute. And you keep whatever you make, whichever coordinate you make your x1, the y value must correspond with him. Same with your x2 and your y2. You don't mix them to you don't mix the coordinates up ever. If x1 is from coordinate A, the y1 must also be from coordinate A. If x2 is from coordinate B, y2 must also be from coordinate B. Always like that. Distance is the same. If they ask for the distance from point A to point B or from D to B, all you do is you substitute whatever you say first. You're going to use B first, you put the x of B and the y of B. You put the x of D and the y of D. Substitute, calculator, finished. Uh, very, very straightforward. Any questions on this, guys? But I will send what is this now? The video on this memo. But okay, I can send it then. But first try it by yourself and then we can see from there. Okay, let us let's see if we can make another. Okay, so the questions continue, and now we have. Let's use a red pen now. Let's use a red pen. So we are given. Okay, pencil. So we are given a graph. It looks like this. Here's our y-axis over there. We have our x-axis over there. This is point C. This is point A. This here is point B, our turning point. The name of this graph is f of x equals 2x squared plus 8x minus 10. Question 1 is saying, determine the x coordinates of the graph of f of x at point A and C. So we must determine the x coordinates here. They can also say x coordinates, they can say roots. Yeah, there's one more word that they can use. But if it's any funny word, it is its x coordinates, its roots, it's yeah, whenever it cuts the x-axis. So to determine the x coordinates, let's do it like this. To determine the x coordinates, factorize the Gauss formula. So to determine this x values, we must factorize this given formula over there. So we start with 2x squared plus 8x minus 10.
Sorry, sir.
Yeah, but we do it this way. We do it this way. There's no formula. You must just know when they ask for x coordinates, you're going to factorize. And you will see why now. You will see why now. Do you want to use a calculator? How do you? I hear you there. It could be a problem. I'm gonna say it would be, but it could be. Let's say they're marking strict and they wanna see steps. You can use a calculator to check your factorizing. How about you do this? Do you see that quadratic formula that minus b plus minus square root b squared minus 4ac over 2a? Use that formula in. All you do is you substitute the numbers, you get your answer. You can use that formula or you can factorize by first you divide by 2 everything, then you're gonna get x squared plus 4x minus 5. Then we're gonna have a x. So the two numbers we have, we must multiply and get a 5. And when we add those numbers, we must get a 4. So it's gonna be a 5 and a 1. 5 times 1 is 5. So we have a positive here. That means our biggest number must be positive. The 5 gets the positive and negative 1. So 5 plus negative 1 gives us 4 plus 4, and 5 times negative 1 gives us negative 5. You can use the other formula to factorize. You get the right answer, you get the same answer. So our x1 equals to negative 5, and now x2 equals 1. So this makes sense. So we can see that our a will be negative 5 because it's on this side of the y-axis. So anything on this side of the y-axis, it's negative numbers. Anything below the x-axis is also negative numbers. Anything above the x-axis is only positive. Anything to the right of the y-axis is only positive numbers. That is why we know that our x coordinates is going to be negative 5 and the y is going to be 0. And for our c coordinate, it's going to be 1 and 0. Okay, so the next question is saying, determine the coordinates of the turning point of the graph f of x at point B. So we need to get point B. Let me rather do this. Let me write down the formulas. Where is this formula? Okay. So If you can remember, was it last night? Was it last night? But last night when we had our session, we also had a parabola in there, and then we asked the same question: determine the turning point of the graph. So to determine the turning point of the graph, we are gonna use a formula called the axis of symmetry first to get the x coordinate of this b. Because the axis of symmetry of a parabola, it falls on the x-axis as you can see there. So the formula for axis of symmetry is saying x equals minus b over 2a. Okay? X coordinate of the axis of symmetry. Alright? This is for the axis of symmetry. The middle, basically the half of the graph. It's the half. It's gonna give you that x coordinate. Then after this x coordinate, we substitute the answer of this x value into the equation of the graph to get our y coordinate. Because the y coordinate is gonna be here somewhere. It's gonna be there, but we don't know. So we're gonna substitute the axis of symmetry coordinate x into the given equation. Okay, let us move in. So the standard formula of a parabola, it is y equals ax squared plus bx plus c. This is our standard equation. And then this over here is the given equation. So we get our values here from our given equation, and our b value is 8, the positive 8, so no brackets. Our a value is a 2, so it's negative 8 over 4, which is negative 2. So our x is a negative 2. Then we take this 2, we take this negative 2, and then we substitute it there. Substitute. Hopefully that's spelled correctly. We substitute. Oh, that's substitute. That is spelled wrong, but okay. But we leave. Okay. Then we substitute this x into there. So it's gonna be f of x equals to 2 minus 2 squared plus 8 minus 2 minus 10 equals, calculator, equals to negative 18. So that means for our b coordinate, it's going to be this x value, which is minus 2, and this y value now, it is negative 18, which makes sense because our b is falling in the negative for the x coordinates of the x range of the graph, and then it's also falling in the negative for the y range of the graph. So it's making sense. This b is also known as our turning point. Our turning point.
Sorry, sir.
Yeah.
I believe that
What is that formula, sir? Yeah, we have our steps here. Yeah, but it's very simple, very, very simple. You take this formula. Let me write like this. You start here, you take this formula, you get your answer. You take this answer, you put it in that one over here, number 2. Number 2, you substitute. You take that answer, then you put it in this form, because you have the x already, you have the y. That's straightforward, simple. You get your marks. That's why I believe that this can be your free marks. This can be your free marks. Definitely. Does anyone have any questions on that? Yes. No, you must know, eh? You must know. But if you look in the group, ne, I did send pictures of the formula sheet, and it's in there for parabola. It is in there. There's even, they gave a nice one. I don't know if they're gonna give you the same one for the test, but it's nicely said. It is put over there for parabola. Let me try and show you. Over here, if you look in the group, man, there it says parabola. There's a formula over there. Okay. Okay, cool. Okay. Is everybody okay with this? This can be good marks if you just be comfortable. Not just be comfortable, but just know what formulas to use. For the one we did before, for these ones, just know what the formulas are for which formula goes with what. Gradient formula is this one over here. Midpoint is that one's. Distance is this one. Equation is this one. Inclination is this one and that one. Just know this, and the gradients, very important, the gradients, because you use gradient a lot to solve the equations. Know which gradient they're talking about, but they can be good marks for you. They can be really good marks. Even this one. They never, they, they rarely ask you anything crazy. It's either the wording, but they would ask you generally the same things. They can't ask you really anything extra or anything fancy.
Mr. B, on your formula sheet.
Yeah, parallel lines, the gradients are equal to each other over there. For parallel lines, the gradients are equal to each other. Okay, a straight line drawn parallel to EB equals to the origin. Okay, let me take a question from past paper quickly. Mm. Okay, let me do one of the circles quickly. Because I will do, you do get circles, half circles, and ellipse, but yeah, I think I will go through that. When can we do that? We don't have to know it now for the test. I believe we can do that after the test. So, this question is looking something like this. It's looking something like this. But more. Yeah. Here is the y-axis. Yeah, I see someone send now the question on half circles and circles. Okay, we'll get to that, man. We'll get to that. Now let's just do this once. Okay, so the question one is saying determine the equation of the circle. So the equation of a circle, it is written like this. So x squared plus y squared equals r squared. Has anyone done maybe work on this, on circles and off circles? Anyone?
I tried yesterday, sir,
Okay, okay. Okay. No, that's fine. So what we do now here is on the circle we have a line that is running on. So we have a circle here. Right? Let's say this is a perfect circle. I can't draw very nicely, but we have a circle here. Let's say it's a perfect circle. So its center, it's at the origin. Let us say that it's at the origin, and there's a tangent, a line that is going through the y-axis and it's going to the x-axis and it's touching on that circle. Okay, it's touching on that circle. Very important. And the only information we have is this. So they want the equation of the circle. So can we all agree that directly opposite to this point on this side, it's gonna be a 2 and a 1, a 2 and a 1 over there, a 2 and 1 over here, because that's a perfect circle. If it was a perfect circle, it would be like that on this graph because the center of this circle is at the origin, at the very origin. So all we do is we take this 2 for the x, we square it, take that 1 for the y, we square it, equals to r squared, the radius. So yeah, this is the radius of the So all we do is we solve this thing and we say this is a 4 plus 1 equals r squared, and then r squared equals to 5. And our formula, our second formula, it's r squared. So we don't have to square root this 5. It is staying like that. So all we do now is we say x squared plus y squared equals to 5. That's all we do for the equation of a straight line. When they say determine the equation of a circle, this is how you must end it. This is exactly the steps you must follow. Nothing more, nothing less. Exactly as is. Okay? They carry on and they ask the gradient of OM. So they want the gradient of OM. So this is very straightforward. OM. But why am I now a bit confused? Okay, no. So OM, right? Let us do this. M. So OM for mom. Wow. Okay. Y2 minus Y1 over X2 minus X1. This is, we know that this is a 0 and a 0. So the Y2, we're going to say 1 minus 0 over 2 minus 0 equals 1 over 2. That's our gradient for OM. For question 3, they are saying the equation of the tangent AB, they want the equation of this line now, of AB in the form y equals mx plus c. So they want the equation of AB in the form y equals mx plus c. And by now we know that we are gonna use this formula over here, right? So it is y equal my minus y1 equals mx minus x1. So we got this, we got the gradient of this one over here. Sometimes you can't always see nicely, but let's see if they say as, yeah, okay. So they are saying that OM and AB, they are perpendicular to each other. So we know that for perpendicular gradients, they must equal to -1. But the shortcut for doing this instead of doing a whole calculation, it's this. So we need the gradient of MAB, right? MAB. But we have a gradient of OM. So all we do is we say the gradient of OM equals 1 over 2. So the gradient of AB is going to equal the reciprocal of this. So it's 2 and the sign changes. So it's -2. So the gradient here is -2. And there's an X there and Y. Okay. So now we must just pick any point that is on this line, and the only point we have on this line AB, it's M, which is 2 and a 1. So the 2 is a X, we put the 2 there, and the 1 is a positive 1, we put it there. Again, we multiply in, that's -2x. -2x is +4, y minus 1. Take this negative 1 over, becomes a positive, so it's negative 2x plus 5. Finished. That's all. That is all. So the next question is saying, what are they saying? They are saying, yeah, sorry, how did I get this to yeah? Can you say again, please? Are you asking that? How did I get this to over here? The next question is saying, determine the coordinates of A and B. Determine the coordinates of A and B. Hmm. Determine the coordinates of A and B. Okay. Let us see if we can determine the coordinates of A and B. So we have the equation of the line AB, and that is y equals negative 2x plus 5, because we have this. This is the equation of line AB. The equation of line AB. Okay, so okay, now we must be a bit of awake, a bit awake. So again, right? If you can remember, okay, yeah. Let me ask. Does anyone know the next move over here? For let us say coordinate A. So we must determine coordinates A and B. We must determine coordinates A and B, but let's start with coordinate A. We do one thing at a time. Who knows the step now for him? Anyone? We did it just now, almost. You're very close. You are very, very close. We must substitute. We must. So anything on the x-axis, his y coordinate will always be 0. No matter the way he sits. Yes. Yes, the y coordinate. So substitute y equal to 0. So 0 equals negative 2x plus 5. Take the 5 other side, it becomes negative 5, negative 2x, x equals negative 5 over negative 2, x equals 5 over 2. Like that, né? Okay, I will do circles another day, guys. And half circle, but okay. That is for the A coordinate. So A's coordinate is 5 over 2, and its y coordinate it's like that. Now, does anyone know for the P coordinate? Remember, anything on the x-axis, his y coordinate will always be 0, right? We know this now. Now for the y coordinate, does anybody know? make x equals 0. Okay, yes. For b, uh, sub x equal to 0. Okay, so y equals -2, 0, plus 5, right? Y equals 5. Ne? So b equals to 0 and 5. Correct. Lovely stuff. Another way for you to see it is that this is a 5 over here. That's a 5, a positive 5 also. And it's on the y. So the c value, y equals mx plus c, the c value is normally on the y-axis. Normally on the y-axis. But yeah, always do this one rather, so you're not 100% sure. You substitute x and y because we know that it's on the y-axis, so his x value is going to be 0. He's on the A is on the x-axis, so his y is going to be 0. B is on the y-axis, so his x is going to be 0. Very straightforward. For those who just joined us now, we determined the coordinates of A and B. So for the coordinate of A, it's same like the parabola. The parabola. What is that now? For the coordinate geometry we did first, the first one we did. So A is on the x-axis, so his y is gonna be 0. So that's why we substituted y for 0, solved x, finished. We're done in the same step again. We're done again. For the B, y, for the B, it's on the y-axis, so his x value is gonna be 0. So we substitute x for 0, solve y, substitute, finish again. That's how straightforward this work is. Very straightforward. Next one. I mean, this question is it's a bit extra, a little bit extra. Let's see if I can put it in over here. So they are saying determine the area of triangle. What is it now? Triangle AOB. It's a bit extra, but don't worry. We all know the formula for a triangle, right? So area of triangle AOB. Can someone tell me the area of a triangle? Anybody? Yeah. So that's the perpendicular height. So right, so for questions like this, it's good to know a variety of formulas. It is good just to know them. You never know. You never know what they might ask. This is a random question. So it's good to know even the simple ones. Just be familiar with it. In the test, even the familiar one, you might put your own things. I've seen people. What formula was this now? For perimeter, I think it was last trimester. People don't know the area for, or the not the area, but the formula for perimeter. It's crazy. Um, but okay. But okay. So equals to half the base, right, is the x value. So it is 5 over 2. 5 over 2. Multiply the height, which is the y value of p, and that is 5. Over now is calculator work. So the area of triangle AOB equals, equals to 25 over 4. If you put it in decimal, it's gonna be like that. And usually they say units. And remember what area? Area is in units squared. It's units because I didn't say meters or anything, so you put units. Okay. So this next one they are saying determine the size of theta, the angle of inclination. The angle of inclination. So if you can observe just what you observe, right? This is the obtuse angle. It's bigger than 90 degrees. So for the angle of inclination, we know that we're gonna use and it's on the line AB and the gradient of AB. It is, yeah, it's this one. Very important to pay attention to this. That this angle is bigger than 90 degrees. That means your answer must be bigger than 90 degrees. If you use the other formula for acute angle, you're gonna get the angle or degree that is much smaller than what it's supposed to be than your 90. It will be less than 90. So 180 degrees minus tan secant function negative 2 equals 1 second. I'm just typing my own things in here. Tan negative 2. So 116,565 degrees. I actually made a mistake now. So when you put this in the calculator, you see how I put the minus 2 there? When you put this in the calculator, you don't put the sign in your calculator. You don't put the negative 2 in your calculator.
Why not say by mouse?
Why actually? I don't know why. Why I can't tell you. But look here. So we know that a line equals to 180 degrees. Yes, 180. So here we get 116,565 degrees. Okay. Let's quickly do the acute angle. Between acute angle 10 to yes, 63 degrees, comma 43 degrees. So this is for the obtuse. For the acute, we have 63,435 degrees. So, so yeah, yeah. Hmm. I mean, that's a possibility, but For me, that's 180 isn't for the quadrant, it's for the straight line. But I will, hmm, yeah, yeah, I hear you. I will definitely, this is gonna, yeah, I'm gonna think about this a lot. Yeah, I'm gonna find out for you guys. I will let you know because I also wanna know now. I also know, but if you can look now, if you put this in a calculator as -2 as it is, look what you get. You get this big number. And we know for the fact that it has to be within 180 degrees. So it can't be this. It has to be, uh, within that 180 at least. And then if you have it normal for the acute now, we get -63. That's also can't be because yes, it must be less than 90 degrees, but it can't be yes. So this has to be incorrect. This is now logical mathematics now. But I will find out about this negative why it can't be in there. Definitely I will find out. But yeah, um just a note. Yeah. Can you put it yeah. No. Yeah, yeah, I see what you're saying. No. No, 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 don't put a negative there. Because if you look over here, on our previous question, our gradient was also positive with a positive gradient. Then when we put it in, we got a reasonable value, the correct value we got. So I think you never put a negative in your calculator because if you go to a trigonometry, right, trigonometry deals with angles as well. So if you do um, your reduction formula, let me try and find it. If I can find it now, when you do your reduction formula for your trigonometry, you never put a negative in the calculator for the reference angle. You never do that. But you know that the only thing the negative tells you for the reduction formula, it tells you that it tells which quadrants you are working in for that either the cos or the tan or the sin. That's all negative tells you. But never do you put the negative in the calculator when you're putting the reference angle. Let me I wanna try and find that for you guys quickly. Over here. So see over here, our angle is it's negative over here. Not our angle, but our number is negative. But when I put in the calculator, it's positive. I don't put a negative because the negative it only tells me which quadrants I'm working in for sin, the third and fourth quadrant. Because it tells me that I must only look at the quadrants where sin is negative. And sin is negative in the third and fourth quadrant. Sin is positive in the first and second, but negative in the third and fourth. So that's all it's telling me. But yeah, if you take a look at the video on this one, you don't understand more. Um, over here also, it's positive. So all I look where tan is positive, which is in the first and I think the third quadrant. Yeah, first and third quadrant. For sun, for sun again, yeah, first and second, it's positive. For tan, where tan is negative, it's second and fourth. And you can see here, there's no negative in the calculator. But I will find out for sure for why the angles is now, we don't do that for the angles for here. I will find out, but just for you know that it's the same principle when you're working with angles. You never put a negative, but when it's positive, you put it as is. But when it's negative, in the calculator, you don't put it. Okay, hopefully I didn't confuse you much now with things. Oh, we actually finished. That was the last question. The question is line form. Yeah. Oh, no. There was one more question. So this question is saying, use a green one. So this one is saying a straight line. It is saying a straight line drawn parallel to line AB passes through the origin. So the line it's passing through the origin, and this line is parallel to AB. Write down the equation of this line in the form y equals to mx plus c. Can anyone give me this answer? For the last question on the night, the last thing on the night, can anyone give me the answer to this question? Anybody? The reverse of the coordinates of AB. How? Remember, it's going through the origin, right? And it's parallel to AB. So what am I gonna write down? I wanna know that formula. What am I gonna write down? Yes. You're gonna use 0, 0, yes. Oh, but you wanna use this whole equation, yeah. But can anyone give me the formula already as it is? Okay. If it's 0, 0, right? If something is 0 in maths, we don't write it most. Yes, right? Yes. Y equals to minus 2x. Because we have no c value, because this line will never pass through any y-axis ever. Never. Your c value is basically your like wherever the line cuts the y-axis. And this green line passing through the origin, it will never cut the y-axis or the x-axis, only at the origin at 0. And we never write the 0. There's nothing. So the only thing we can write is the gradient and this x value over here. So not x value, but y equals minus 2x. It's basically this y equals mx. The standard formula again is y equals to mx plus c. Y equals minus 2x plus 0. It's basically that. It's cutting through 0. Yes, it's cutting through 0. Yes. Or the y, it is. But in maths, we never write 0 like this. We end it like that. Y equals to minus 2x. Well done to you, sir, for getting it. hopefully you guys, you feel a bit more better about this work. Don't worry about circles and half circles and ellipse. I will get to that one. But we won't do it for this test. We will not cover that. Unless I can find a video, but it's very straightforward. It's very straightforward. As you can see over here, like this is literally all you do. But I will want to cover with you, so it'll be okay. We'll get it after the test for sure. Any questions by anyone? Let me know. Okay. Everybody is happy chappies. Okay, call it a night.